Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the International Society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotechnical Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Iman Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. with the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully, thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in their curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
Nestled among the mighty Himalayas stands a temple of education, an institution that shapes young minds of today into ambitious, conscientious, and dauntless individuals. Individuals who will become leaders of tomorrow. This is Jaypee University of Information Technologies, Solan, where education meets excellence. Conceived as the joint vision of the Government of Himachal Pradesh and the founder chairman of Jaypee Group, Shri Jaiprakash Gaur, JUIT Solan is the first private university of Himachal Pradesh established in 2002. Over the last 2 decades, JUIT Solan has been relentlessly pursuing its mission of contributing to a better world by cultivating creativity and advancing fundamental knowledge through education among students. Adorning the picturesque slopes of Waknaghat hills in the Solan district of Himachal Pradesh, the university campus spread across 25 acres provides a peaceful and serene setting in the lap of nature for young minds to hone their skills for a brighter future. JUIT offers undergraduate, postgraduate, and doctoral programs in various fields of study to include computer science and engineering, information technology, electronics and communication engineering, biotechnology, bioinformatics, civil engineering, and management.
JUIT has been producing polished graduates who are working as experts in various fields in country and abroad. More than 200 alumni have become acclaimed professionals in countries like Canada, America, and also Europe.
As Dean Academics and Research, I have had the privilege of witnessing a remarkable journey here. We aim to provide an educational opportunity to one and all, irrespective of their background. In JUIT, our main aim is to produce industry-ready professionals and good human beings. From the beginning, our institution has been known for its research and innovation, and now it emphasizes on interdisciplinary research and collaborative work. We are also aligning with the principles of NEP 2020, and following NEP, we are preparing the students to excel in their professional journey. We have been continuously ranked in NAC and NIRF. Now we are also ranked in international rankings such as the Times Higher Education ranking and QS ranking.
We regularly upgrade the IT infrastructure at our university. Recently, we have added a good number of new machines in various labs.
With modern hostels for both boys and girls, faculty residences, a healthy and hygienic students' mess, auditorium, sports facilities, and other amenities. The university campus makes life vibrant and enjoyable for students, both inside and outside the classroom.
Handling 1900 students in the age group of 17 to 23 years is challenging. In JUIT, we create a conducive ecosystem for a student to develop and nurture his or her personality besides the academic curriculum. Providing excellent amenities in the hostels, good nutritious food, active sports fields, vibrant and diverse co-curricular activities, clubs, NCC, etc. are all domains which fall in my responsibility as the Dean of Student Welfare.
The university exposes its students to placement teams from several well-known companies. and the students here in this university to get placements in the organizations like Microsoft and Amazon.
JUIT Solan stands tall as an institution committed to academic excellence, holistic development, and industry relevance. With its focus on research and innovation, as JUIT graduates step into the professional world, they carry with them not only knowledge but also the skills, values, and perspectives necessary to make a positive impact on society.
So, hello and very good morning to everyone. Welcome to the third lecture of the lecture series conducted by IGS Shimla chapter and Civil Engineering Department JUIT Waknaghat on advances in geotechnical engineering. We are very happy that you have shown enormous great numbers in participation over the last 2 days, and we hope that you will be able to join us in the coming lectures as well. So with this, I cordially thank to all who have joined in this session, including the members of the IGS, elite members of the engineering community, and also the students. So have Dr. Rajesh joined. Dr. Rajesh, are you able to hear me?
Hi, you are audible, Dr. Niraj.
Okay, thank you, sir. Thank you very much for joining us with your very busy schedule these days. So can we start with the lecture?
Sure.
Okay, so everyone, before we start the lecture, let me give a little introduction about the speaker of the day and Dr. Rajesh Prasad Shukla. So Dr. Shukla did his Bachelor of Engineering from Government Engineering College, Rewa, Madhya Pradesh, and then he did his Masters from IIT Kanpur over the dissertation topic, pile foundation subjected to excavation-induced loading. And then he did his PhD from Earthquake Engineering Department, IIT Roorkee, over the thesis titled Skirted Foundation on Slopes. He's currently working as an assistant professor in IIT Srinagar. His areas of interest include foundation engineering and ground improvement. Dr. Rajesh Shukla has more than 20 research papers in his name in the top international journals and conferences, with major works on failure mechanism of footings, load-bearing capacity of skirted footings, footings on cohesive and non-cohesive slopes, pile groups and their failure mechanism, and use of sustainable materials and industrial byproducts in soil stabilization. So with this, I heartily thank Dr. Rajesh for joining us and for enlightening us with his lecture. Sir, over to you. You can please continue with your lecture.
Thank you, Dr. Niraj. It is really very nice introduction. And earlier presentation, I have attended earlier 2 presentations also. They were very engaging and very informative. And we have learned a lot from those listening about what you can say, IGS President Anil Joseph sir, as well as our Samadhiya sir. I will try to keep very simple considering the, what you can say, many of here present are the BTech and MTech student. So I will keep something like that is easy to understand them, not so much software based. So thank you. So can I share my screen?
Yes, sir. Please.
So I hope my PPT is visible to everyone. Dr. Niraj?
Yes, sir, it is visible. Thank you.
Thank you. So this is the content of my presentation. First, I will discussing little about what is the slopes, what are the foundation, then modeling details of those problems, and then I will discuss first foundations on the level as well as the sloping ground under static and dynamic loading condition using the constitutive modeling. What is the advantage of constitutive modeling? Here we can get the load settlement curve also along with the bearing capacities. Then foundations on the slope again using the experiment and the 2D FEM modeling. Then bucket foundation on the slopes. I will try to cover maybe the initial two portions, considering the time is restrained. So let us see. So we already know what is the foundation. So basically foundations are designed to safely transfer the load of the superstructure to the ground. And foundations can be classified into shallow and deep foundation. And it is very generally, common understanding is that key depth of foundation, if less than the breadth of footing, we can say shallow foundation. And if the depth of foundation is more than breadth of footing, we can say the deep foundation. But this is the common understanding. This is not the real definition. This is the initial thought process when we are dividing the foundations based on whether they are deep or shallow. So what is the purpose? As I see, it is basically to transfer the load safely to the ground. First, without failure of the soil, without compromising the safety of soil or without the shale failure. Then the settlement of the foundations should not exceed the permissible settlements, and there should not be excessive settlement. So second criteria, that is the settlement, that is just called the serviceability criteria. And first criteria is called the bearing capacity criteria, where we don't allow soil to be fail in the shear. Sometimes the settlement also poses problem under the sloping conditions. Suppose if ground is sloping or earthquake loadings are there. So it is very common, even in the normal condition, we can have the either tilt or differential settlement. It is very difficult to have the uniform settlement. So this is the disadvantage of the slopes or seismic loading conditions. So sometimes what is happening, we design our superstructure very strong, and foundations also very strong, but what is the problem with soil might be failing. So even after designing very good, very strong foundation, a strong superstructure, they are really failing. We have different, our history, we go through our history. So we have seen the number of buildings, like you can see here, during the earthquake loadings, many buildings have been collapses, many buildings have been tilted down, some are still standing, we can see in the second plot. The reason is just only soil here. The behavior of soil is different at the below the different building. So they have behaved differently. Here we can see here, superstructure itself is very weak. Here we can see pile foundations are in little bit tilted here, you can see here, but almost all our piles are intact there. So we can say here strong buildings with a strong foundation with big soil. Here we can see here building is almost intact. For what is happening here, foundation was the big. So these are the conditions we have to take care of in the real scenario. So as we discuss about the deep and shallow foundations, so the real criteria is the failure criteria. We can classify any foundation, whether it is a deep or shallow, just based on their failure criteria, not based on the depth of foundation in generally. So if we see in the shallow foundation, generally we can see the punching, or maybe mostly we can see the general shear failure. So generally what is happening when we apply loading on the foundation, so first what is going to happen, elastic deformation will be a little bit elastic deformation. If we remove the load, it is again regain its original position or original shape. After the elastic deformation, we have the local cracking from the sides, because this footing is almost, you can say, rectangle footing or strip footing. So there will be the concentration of the stresses at the corners. When there is concentration of stresses at the corners, we have the local cracking, where around the footing or around the corners. Then we have the wedge formation here. Then finally development of the rupture. So this is the development of the failure modes, how it has been developed. And if we similarly we see in the load settlement curve, same things will be reflected here also. Initial portion is straight line, stress is proportional to strain, almost, even I can say here it is the elastic region. Then we have the transition state, where it is between just plastic zone is developing, and here again we are going to get the linear portion. Again here slope is constant. So this is again we are having the plastic region. So this is generally we see this type of the failure in case of this. If your soil is strong, we can see in case of general shear failure in the shallow foundation. Sometimes our soils are not very good, then we can have the local shearing also. So now if foundations are very deep, if you see, this is the df by b prime plot versus the relative density. We can see here if density is high, generally our depth is less, d by b ratio is less than 3, we can see the general shear failure. Similarly, when relative density reduces, and for the same depth or little more depth, we have the local shear failure here. But punching, you can see when depth is d by b ratio, this b prime is nothing but a 2bl divided by the b by l. When this ratio is getting more than the, I can say 5, we can say 5 or 6, we generally see the punching shear failure. Then the behavior of foundation becomes independent of the relative density. What we can see here, the failure pattern is independent of the relative density of the material. It is always going to be the punching shear failure. So this is the something transformation of the failure mechanism when we are going from the shallow to the deep. When it is the shallow foundation, we can see journal or maybe the local shear failure. Then when foundation, that D by B ratio is more than the 5 or 6, we can see the either the punching or very confined. At the intermediate level, we have the confined failure also, when this failure surface doesn't reach to the ground surface. So in this basis, we have to really classify the foundation, whether they are shallow foundation or deep foundation, not based on the D by B ratio. Now, as the topic of the presentation is the foundation on the slopes. So slopes, in generally, when we ask some question to any students, even after the BTech, even after the MTech, or when they are appearing in their PhD interview also. So what is happening? Suppose some students have worked on the foundation in their master thesis. So when you're asking what is difference between the infinite slope and finite slope, they hardly able to answer this question really. So generally we think that the infinite slope is any slope that have the infinite length, infinite extent. So if something is infinite, we never see any slope infinite really. They doesn't exist. Does they exist? I don't know. We cannot say they exist. At least they doesn't exist in the earth. Similarly, finite slope, most of the time we see man-made slopes like the embankments are there or dams are there, or many natural slopes are also finite slope. So what is how we can classify slopes, whether they are the infinite slopes or they are the finite slopes? So basically, the criteria for the infinite slope, because they don't know, most of the students don't know what is the infinite slope, even after the getting their degrees. So when we say what are the different criteria to define any slope as an infinite foundation, first is the thickness of the affected zone is relatively less than the depth of the length of the zone. So if we say this is the affected area or where landslide occur, so what we can see, or having the chance of failure surface is developed there. So when we see that this length, if we zoom out any surface, failure surface, and we see that this is the length of that affected zone, this is the depth of affected zone. If this D by L ratio is less than, I can say 0.1, then we can say this is the infinite slope. This is the one certain initial criteria. Then failure plane is always going to parallel to the slope. What is the second criteria here? In case of the infinite slope, in generally they have the failure surface parallel to the slope surface. So what we can say here, this failure surface is almost parallel to our slope surface. This is the second criteria. Then third criteria is the soil property doesn't vary with the depth. So up to the certain depth, this depth soil property is going to same here also, here also, here also. Other issue is the, even we can say that the variation of the vertical stresses, this should not vary with the depth. That is the generally. So these are the criteria needed to be satisfied for the infinite slope. If this criteria is not satisfying, it means that slope is going to the finite slopes. And here the soil properties might be varying with the depth also. So this is basic difference between the finite slope and infinite slopes. Then why we need to study the foundation of the slope? Like I think JUIT itself has been constructed or built on the hilly region. So might be some building might be still on the slope. So here we can see number of buildings are there in the slopes. Sometimes we can see abatement of the bridges also, they are subjected to the, they are constructed on the slopes. Buildings, here again buildings we can see here. Then we can see here towers are there, electric towers are there, their foundations will be constructed on the slopes. And this is the picture of Shimla city itself. So what we can see here, before almost some year back, this was the picture of the Shimla city. Now we can see how much development is there. So almost all the buildings are resting on the sloping area, and their slope failure is very common. Here we can see again abatement, all those things resting on the slope. So therefore we need to design, or we need to determine the bearing capacity of foundation on the slopes.
So sorry to interrupt in between. Can you please hide the notification at the bottom of the presentation?
Okay. Thank you, Dr. Rajesh. So these are the methods of determination of, there is different method of determination of bearing capacity. So generally at the BTech level, we consider limit equilibrium methods like the Terzaghi, Merhab. So they have considered the equilibrium of moment or equilibrium of the forces. Then we have the strip line methods. Generally in the master level or PhD level, people are working, researchers are working on this method, limit analysis method. Here again, we have the upper bound method and lower bound method. In the upper bound method, generally we keep the work done by the external force equal to the rate of work done of external force equal to the rate of work done by the internal mechanism. Then we are going to get the collapse load more than the real collapse load. So this is the problem with the upper bound analysis. Whatever load we are getting here, that is going to be more than the real load. In the lower bound analysis, we never get the collapse load because the determined load is going to always less than the collapse load. So we cannot say the word collapse load. So the problem with the limit analysis is that we don't have any idea about the settlement. We just have the bearing capacity there, and that also the more than the actual collapse load or less than the actual collapse load. So if you want to do the really get the accurate bearing capacity, like the many researchers have tried to find out the accurate bearing capacity, then what is the solution? We have to use the upper bound, then we have to use the lower bound both. If the difference between the lower bound and upper bound is very small, then we can say we are able to determine the real collapse load or real bearing capacity. But what is the problem here? They don't consider the settlement. So we don't have any idea about the settlement. So this is the problem with the limit analysis. Then we have the different empirical equations also there to determine the bearing capacity of the slope of the foundations, maybe on the level ground or on the slopes. Those are basically depending on the different experiments or earlier things. Now, experimentally, we can determine based on the small scale or full scale. Again, small scale can be classified into 1G testing or centrifuge testing. Or full scale. In generally, we never perform the full scale testing. What is the reason? We don't have that much fund or money to do the number of experiments full scale. Now, what is the problem in case of the slope? So, in generally, if you see, this is the failure mechanism that is mostly available in the any BTech, if you any book. So here, what we can see, this active zone or elastic zone is completely developed here. You can see here, radial zones are also developed here. Passive zones, passive resistance is also coming perfectly here. So here, what I can see, the confinement is full here. But here, because of the slope, here confinement is going to less. Now, the failure surface is symmetrical. Failure surface is symmetrical. What we can see, we can analyze this problem half only. And we can just multiply by the 2 and we can get the bearing capacity complete. So here, the failure surface is very symmetrical. It is very easy to assume this failure surface. Now, in this case, it is very difficult to even assume also. And the problem is that they are not the symmetrical one. It depends on the location of the foundation. There are a number of factors affecting the failure envelope, failure surface. No slope stability problem. In case of the level ground, we don't have to worry about the stability of the slopes. Slope, there is no slope. But in case of the slopes, first we have to make sure that the slope itself is stable. Slope itself is stable. After that only we can start the construction. If slope is not stable, then we have to go for the ground improvement techniques and then construct the foundation. So this is another one issue that we facing in case of the slopes. Sometimes slope itself is failing, and sometimes what is happening, slope might be stable before the construction of building or maybe the construction of single or two-story building. If you do further construction, they might fail, slope might fail itself. So this is also one problem. So we have to take care of all these issues when we are making construction in the slopes. Need not to consider the geometry of the slopes. Here we have to see the geometry also. What is the location of foundation from the slope is also, whether they are resting on the slope itself or away from the slope. Those things we have to consider. Significant resistance against the outward lateral movement. When soil is moving outward, literally there is so much overburden pressure is there. So that is going to restrict or reduce the rate of lateral movement, outward lateral movement of the soil. Here we have lack of the resistance against the lateral movement. And what is the other issue? This side of soil, sloping side of the soil fails before the failure of the level side ground. So there is no mobilization of the shear strength of the soil. So what is happening in the sloping region? There is partial mobilization of the shear strength of the soil. However, complete mobilization of the shear strength of soil. However, in case of the level side, there is only partial mobilization of the shear strength of the soil. So this is the problem here. So these things make the problems very complicated. If suppose in case of the slope also, there is further earthquake, the earthquake loading further is going to reduce the factor of safety of the slopes or load carrying capacity of the soils here. So in general, if you want to simulate the seismic loading, if you don't know seismic loading, I can simulate the seismic loading by the eccentric incline loading also. It is almost having the same effect. So we can simulate that also. Now, if we talk about the codal consideration or codal provisions, so we can see our Indian standard IS 1904 1986 have some guidelines, but those are very broad guidelines. They doesn't really help us much. These are very common. These designs or these guidelines doesn't depend on the soil properties or foundation size, slope size. So many parameters are there. But what is there? What if they are saying the distance between the slope and the base, what you can say, outer edge of the foundation should be more than the 900 mm. This is the minimum. You have to keep more than this one. Other issue is that these lines joining the two foundation, because we never construct single foundation. In a building, we have the number of foundations. So these two, we suppose there is two isolated foundation or footing itself are there. So what is, if the line joining the outer edge of these two, slope should not be steeper than the one vertical to the two horizontal. So these are the guidelines that given in the Indian standard. So we can see here these guidelines are not enough to make any construction on the slope. So like we have the Uniform Building Code also, or we have the international residential code also. So here also we have the very common guidelines, not any specific guidelines. They don't consider the so much slope effect. They don't consider the type of the building, type of the slope. So this is the problem with the almost. Then we have the ASSTO 2012. This is basically, these graphs are graphs taken from the Mayor Hub itself. So they have little bit directly they have taken the Mayor, what you can say, plots from the Mayor Hub study. So Mayor Hub, in his first time, Mayor Hub tried to determine the bearing capacity of foundation on the slopes. And these charts have been directly taken from the Mayor Hub. So now coming to my problem. So first problem is just foundation on the slopes. So this is the FEM analysis we can see here. Second, this is the strip footing resting on the slope. Second case was the isolated footing resting on the slopes. Then multiple footings, two footings resting on the slopes to find out the interaction effect. Then skirted foundation on the slopes. Then bucket foundation on the slope. So we have tried to find out what is the effect of different type of the foundation on the slopes. So for the bucket, we cannot go for the plane strain condition. So we have used the 3D modeling here. So we are able to define the problem as a plane strain problem in case of the strip footing or in case of the skirted strip footing. So we have used the plane strain conditions and 2D modeling. For here, for the isolated foundation and the bucket foundation, 3D modeling have been used. So I'm not going to the detail of the numerical modeling so much. Just we have to see, before starting any numerical modeling, we have to find out how many actually elements are required to perform the analysis. So we have to increase the number of elements one by one, or whatever is possible if you are using any Praxis or GeoStudio, or if you are using the Optum, anything. So first try to find out what is the optimum number of element to perform the analysis. So in this case, we have increased and we found that when the number of elements more than, I can say, 5 or more than 10, they are becoming the constant. So here we can see 15 number of elements are more than enough. Then number of iteration. So nowadays it is very common practice in the softwares. What softwares are doing? See, it is, we have that so many number of elements in case of what you can say. We are designing, simulating the soil element. So now, if you are doing any numerical analysis, if you want to see, all the numerical analysis are just black box, something like thing. If you don't understand what is going there inside, it is very problematic. We have to understand what is going inside, or then we have to, after analysis, we have to compare our results with the earlier studies also. Whether we are getting almost identical result or not. Because in the software, if you give any input, they are going to give you some values. They might be right or they might be wrong. So we have to make sure that our modeling or software is, or our model is validated. So for validation purpose, we have to compare our results with the earlier studies. So in our case also, we have tried to compare the results with the almost all the previous studies. So we can see here, they are neither on the very lower side nor on the higher side. So almost we are getting the almost close to the like the Kumar have used a lower bound FEM analysis, Martin used, there are a number of analyses. So we can say that the results from the present modelings are almost close to the earlier studies. Then we have determined the NQ means the bearing capacity factor because of the surcharge. And this is the bearing capacity factor considering the weight of the soil. So we have compared these things and we found that they are within the range of the earlier studies. So we can rely that whatever model we have developed or we have made, those are giving the almost accurate results or results within the consideration. Now further, these are the comparison of the results with the earlier results. We can see here they are giving the good results. This is the black color is the present study, you can see here. So this is for the N gamma, then N gamma Q. So if you see, Terzaghi has given the NC, NQ, N gamma differently, 3 bearing capacity factor. But what is the meaning? It means Terzaghi first considered soil to be the weightless one condition, other condition without the surcharge loading, in other conditions just only the C. So here this is the bearing capacity factor which combinedly consider the effect of the gamma as well as the surcharge. So this is the one new bearing capacity factor. Similarly, this is the bearing capacity factor under the seismic loading condition. So our model results has been compared for the slopes under the static condition, foundation on the level ground, strip footing on the level ground, isolated square footing on the level ground, then on the slopes, then under the seismic loading condition. So after this so much comparison, we can say that the model is giving the perfect results. Now some experiments are also performed to validate the results. See, we cannot rely just only on the previous results, they are good, but we can do some additional experimental testing also to find out that their load settlement behavior also. So this is something model tank was there, it is 2 meter length and the 1 meter breadth was there. This is the hooper, and here number of arrangements have been made to control the rate of sand fall, because if height is more, we can get the more density. And this is the flexible skirt. We can see here, these are the small strip of the cast iron. You can see they may bend also. So we have defined them as a flexible skirted foundation. Then this is the rigid foundation. Here we can say these are very thick and they are not going to bend. They will not subject it to any deformation. So this is the rigid foundation. Then this is the foundation you can see, and then filling up the sand here. So how we started on the slopes? It is very difficult to make the slopes on the experimental testing. So first we filled up to some time level high, up to the level ground. We make something ground here, generally filled. Then we have tried to make the slope geometry, because we have to analyze the foundation under the different sloping condition. So with the marker pen, we try to mark the slopes here. Then after filling it, we used to fill one by one slowly, and we can see there, you can see here clearly how slope has been formed. Perfectly we have able to make the slopes in the lab itself, exactly whatever we have drawn here. After that, making that slopes, we have to see whether that ground is level or not. It is up to you what do you want to check. Then after placing the foundation, initially foundation should be the level. So we have checked with the hierarchy whether foundation is already tilted before the testing or there is no tilting there. So we have to make sure all those things in the experimental testing. Then we have to apply the loading. After the application of loading, we can observe how the failure surface is developing. We can see here below there is no change in the layers. They are almost intact. But up to certain depth we can see here there is compression is there. But here the failure surface, that is very shallow failure surface we can see here. So this is the experimental studies have been performed. So now first I will discuss the strip footing on the slopes using the constitutive modeling. So I will consider this only case in the today's presentation. So what is the constitutive modeling? So constitutive modeling basically deal with the stress and strain relationship of any material. So now let us consider any foundation. This is our foundation. This is the foundation. This is the superstructure, and this is having the B, and this is the ground surface. It is having the depth, and this is superstructure. So horizontal loading can be at anywhere, and during the earthquake loading also, we have this horizontal loading cannot act here, what you can say, at the base of the footing. It is always going to be some height there. So that most of the previous studies have neglected the effect of this height there. Basically moment, we can say moment at the base of the footing. So in this study, the moment has been also considered. So this is the one advantage of this study. And this is the cases you can see here. Moment is also there, vertical loading is there, horizontal loading is also there. So when moment is, so we can see here, what is the eccentricity m by v prime, all those things. We know what is the q max here, what is the q minimum here. Already we have studied in the BTech level. So now, what is the, this is the, we generally don't get the symmetrical failure surface in the case of the seismic condition or in case of the sloping condition. So sometimes we have the maximum settlement one side we have the minimum settlement. If tilting is more moment is there, we sometimes have the negative also, S minimum also, and here S minimum also. Sometimes we can get the 0 S minimum also. So these are the some things here, or S average, S maximum plus S minimum divided by 2 into B. We are calling as A, here CG is there. So we can get the average settlement. So average settlement equal to the S minimum plus S maximum divided by 2. So now there are a number of mathematical models have been given to determine the relationship between the stress and strain. So this hyperbolic function has been given by the Condor in the 1963. So basically this is the strain equal to some constant into sigma 1. These are the principal stresses. Sigma 1 minus sigma 3 divided by 1 minus this B also constant, sigma 1 minus sigma 3. So total settlement, if you want, so we can integrate settlement along the vertical line. So we can get the total settlement here. So how this model, basically we can get these A and B parameters. So if suppose we have to make foundation any particular soil, so we can do testing on that soil and we can get the stress strain plot. Basically diabatic stress versus the axial strain. We can do the triaxial testing and we can find out this plot. So what we can see here, this is the initial tangent modulus. So initial tangent modulus equal to 1 by A. Similarly, this is called, we are considering the effect of the elasticity or stiffness of the soil. Then this is the strength, because soil have the stiffness as well as the peak strength also. So both parameters should involve in case of this mathematical model. So this peak sigma 1 minus sigma 3 ultimate equal to 1 by B. So in this way, if you perform the testing in the lab, triaxial testing, we can get these two constant A and B. So these two constant are the function of the type of the soil. And this is something like that. Or if you plot strain divided by 1 by sigma 1 minus sigma 3 diabatic stress, or strain in the x-axis, I can directly get the A or I can directly get the B here also. So both ways the possible. So now these are some equations that we have used in the present analysis. How to get the sigma z stresses because of any loading at any particular depth in the z direction, x direction, and the shear stress. So there is number of equations. Many people have given, many researchers have given the different equation to find out the different sigma, either sigma or tau. For the line loading, different type of the loadings. Again, we can see here, these are the function of the Poisson ratio also. So we have the sigma z in the vertical direction, sigma in the horizontal direction, and the shear stress, because we are considering the 2D problem. So here we can see here sigma z, sigma x for the horizontal loading. So now what we are doing here basically, so we have seen that most of the time P is not going to also constant. So here we can give the something Prasad diagram, something like that. So what we are doing here basically, we are dividing the whole pressure zone into different area, and then we are determining the area. And then we are saying the P1 force, P2 force, P3 force, P4, P5. So we have the number of forces. So because of these forces, we can determine the stresses at any point using the earlier given equations. Similarly, for the horizontal loading, we have the number of horizontal loading. We can find out the stress at any point A, what is the stresses generated because of these Q loading. So in this way, first what we are trying to find out is stress at any point. Now, if I have the stress, I can get the strain also using this hyperbolic function relationship. So I have already stresses, and stresses I determined sigma 1, sigma 3 using those equations. Now I know what is the soil properties. What is soil property? A and B are the function of the soil. Now I can get the strain at any point. So in this analysis, what are the basic assumptions? The soil is semi-infinite, isotropic, and foundation is considered as the rigid strip footing here. And if you are considering the soil, in one case we have considered the saturated soil, other case we have considered the dry soil also. So here the whole soil mass supporting the footing has been divided into number of zones. So this is the something footing is there. So we can divide into the different, we have first marking the different points on the below the footing. 1, 2, 3, 4, 5, 6, 7, 8. It depends on the you only. If the length of footing is, breadth of footing is very high, you have to consider more number of points here. Then we are drawing the vertical lines here along with that. And then we are determining the stresses because of superstructure loading at different points. What is the stress here? What is the stress here? What is the stress here? So at the all the points, these points 1, 2, 3, 4, 5, 6, all points we are determining the stresses vertical. Here stress, here stress, here. So all the points, first step is determining the stresses using the earlier given equations. Here also, here also, here also, here also. Then we are finding out the strains. Now I get the strains at this point, I can get the strain at this point, strain here, strain here, strain here, strain here. Now if I integrate the strain from this point to this point to this point, I can get the settlement. Similarly, we have to integrate the strains from here to here, and we can get the settlement. Here also, here also, here also, here also. So we are getting the settlement also. We already have the stress, and we can get the strain, and then we can get the settlement also. So these are the sum of equations to get the strains in the different directions here. And if you want to get the vertical strain, so vertical strain is equal to strain in the vertical direction total. And this is the sigma strain in the third direction. And this theta is the angle between the principal stress and the then settlement equal to number of layers 0 to n. And we are just integrating that strain. So if we see how we are getting the load settlement. So what we have kept the different loading condition, different surcharge, different loading of the superstructure. First case we have we are just increasing Q equal to 25 kPa, Q equal to 50 kPa, Q equal to 67 kPa, Q equal to 75 kPa. So what we can see here, when we are increasing the superstructure loading there, what is happening you can see here, settlement is also increasing. So in case of the 75 kPa, what is the maximum settlement you can say center? Almost 30 mm. So here we are getting the settlement. So this is the settlement profile. So this is the advantage of constitutive modeling. We are getting the settlement also. Here also we have plotted different settlements here. We can see here for the dy b equal to 0 and breadth of foundation equal to 1 meter. Then dy equal to 0.5. So if you keep your foundation at larger depth, what is going to happen? You can say settlement has been reduced. Earlier the settlement was the 30 mm. You can see maximum settlement here for the same loading. When increasing the depth of foundation, you can see here from the almost 32 to reaches to the 20. So settlement has been reduced with increase in the settlement. We have further increased the depth of foundation. It is to the 16 you can see. So with increase in the foundation depth, we are getting the smaller amount of settlement. So this is the settlement profile below the footing. Now we have developed some equations also. So when we have developed, so this is the QUAH. AH means seismic loading divided by the Q ultimate under the static loading condition. So this is the equation 1 minus, these are the constant, A1, A2, A3 are the constant, A is the horizontal acceleration. And this H is the where the horizontal force is acting. This B is the breadth of the foundation. So we can see here, these are the constant value. If I know the bearing capacity under the static loading condition, that you can determine using the any formula, I can get the bearing capacity under the seismic loading condition using this equation. Similarly, what is the S max at the under any seismic loading condition divided by the S average under the static loading condition. If I know the S average under the static loading condition, I can get the S max under the seismic loading using these equations. So these are some equations. Then S minimum divided by the S average. So you can see we can find out the S maximum also, S minimum also under the seismic loading conditions. So this is the validation. So this is the for particular soil, the triaxial test has been performed. After that, it has been modified, and we have got the 1 by A, A and B value. After getting this A value, so this is the experimentally obtained footing. If we do the testing on the footing, so we got something, this settlement profile, and using the present methods, we got something like that. So this is the, using the proposed method, we have got the settlement profile. Now let us solve any problem here. So what is the problem? Determine the amount of vertical load that a strip footing of breadth 1 meter resting on the saturated clay. This is the property of clay. You have to do the triaxial testing. I can get the 1 by A value also. So this is indicating the stiffness of the soil. And this 1 by V is considering the ultimate strength of the soil. So both have been considered. We are not just only considering the stiffness or strength. We are considering the both things here. Located at the depth of 0.5 meter below the ground surface. Consider the factor of safety against the serial failure to be 3. And the permissible settlement how much? 20 mm as per the code is there. So what we have to do using these equations? So d by b equal to point. What is the here depth is given us? Depth is given 0.5 meter. So first we will consider the, and breadth of footing is 1. So I can say d by b ratio is going to be the 0.5. So using this equation, QU at d by b 0.5 divided by the QU d by b 0. So basically that we have to find out. So first we have plotted this plot for the footing resting on the ground surface. From here, what we can get? We can get that the ultimate capacity is the 108.14 something. 108 point. If you draw something tangent from here, I can get 108.14. So this ultimate bearing capacity we got from the this load settlement plot for a particular soil with particular properties. Depth is 0. Horizontal loading is also 0 here. Then this equation has been already proposed in this study. So 1 plus 0.262 multiplied by the 0.2. So this is the equation. So we got how much? We got the this ratio, bearing capacity ratio, or I can say depth factor. So depth factor comes to the 1.131. So when we are increasing the depth from 0 d by b ratio 0 to 0.5, the bearing capacity will increase by the 1.131. So 1.131 multiplied by the ultimate bearing capacity that we got from this plot is equal to 122.30 kilonewton per meter square. So we got the ultimate bearing capacity at the depth of 0.5 meter. This plot is for the 0 meter depth or foundation resting on the ground surface. Now safe bearing capacity equal to ultimate bearing capacity divided by the 3. So we got the safe bearing capacity also. Now let's find out the settlement also. So settlement, when this settlement is footing is resting on that ground surface. Now if we suppose that same footing is resting on the at the depth of 0.5 meter or d by b ratio is 0.5. So this equation was proposed 1 plus 0.064 d by b minus 0.033 d by b ratio. So we have to keep the value of just only d by b ratio here, and this is the ratio of the these two. So I can say here SU at the particular d by b ratio equal to this multiplied by the SU at the 0 depth of the foundation. So we got this to be the 4.2, which is less than the when foundation was resting on the ground surface. So what we can say here, the settlement of foundation has been also reduced with increase in the depth of foundation. So this is the method, or this is called the constitutive modeling. So what we can see, we can get the not only the settlement, we can get the ultimate bearing capacity, we can get the safe, or we can get the settlement correspond to the any pressure also. That is also advantage of this constitutive modeling. Now suppose same example is there. Now it is subjected to the seismic coefficient of the 0.1, horizontal seismic coefficient of 0.1. So now, and consider the horizontal seismic force act as a height of 2.5 meter from the base of footing. So from the earlier we have the solution d by b ratio how much? 0.5. H by b equal to horizontal force where it is acting 2.5 divided by the 1, it means 2.5. So from earlier numerical we got ultimate bearing capacity when horizontal force or seismic force was 0. How much bearing capacity? 108.14. Now this is the equation that present study proposed to determine under the seismic loading condition. So this is the ratio of bearing capacity under the seismic loading condition divided by the bearing capacity under the horizontal loading condition. So this equation has been proposed. So keeping the value of A1, A2, A3 and H by V. So this comes to the 0.7565 if keep all the values. So ultimate bearing capacity under the seismic loading of, or I can say alpha y, alpha of the 0.1, it comes to the what you can say 0.7565 multiplied by the bearing capacity in case of the seismic loading condition. So it comes to the 81.80. So From the load settlement curve, what we have did? We determine the bearing capacity for a footing which is resting on the static loading condition, that also on the ground surface. Now we can find out the even the seismic bearing capacity also. So therefore it will be noted that the safe bearing capacity due to the seismicity decreases from 40.7 to the 27.27. So we can see here, because of the earthquake loading, the bearing capacity has been reduced significantly. So this is the constitutive modeling. Let me see how much time do I have further. So almost now we can see we can get the S max under the seismic loading condition divided by the S average in the horizontal loading condition, or when there is no seismic loading. So this is the ratio. We are going to keep the value of this constant and the seismic coefficient and the H/V ratio. We can get the settlements also. So we can see a settlement is increased because of the seismic loading also. So these are the some of the examples. Then we can find out the not only the S maximum, we can find out the S minimum also during the earthquake loading condition if I have the S average under the static loading condition. So these are some important, what you can say, consideration or important application of the constitutive modeling. We can determine the tilt also, because if I know what is the S maximum, what is the S minimum, I can find out the tilt also. So tilt is also, we can get it. So this is the advantage of the this constitutive modeling. We are getting the tilt also, we are getting the S max also, we are getting the S minimum also for seismic loading condition or maybe the static condition. So we don't need any software. See, these are the very complex problem. If you know the constitutive modeling, we can use the different models, just not only this model. So students can use any models given by the researcher, and they can develop their own equations or own bearing capacity also, equations also. So if suppose loading, suppose in case of the sloping ground, suppose our ground is very sloping. So what we can do, you can see here there is nothing is there. So what we consider, this soil is already there. So we consider some upward loading here to compensate this downward loading. So this upward loading is going to compensate the soil below this one. So it is going to give the effect of the sloping condition. We can see here something like that. So this soil have the downward stresses. So I'm applying some upward loading here. So because of this upward loading, because of this down loading, effect is going to be the same here. So here also same analysis we have carried out for the strip footing resting on the level ground. Then we got the load settlement curve for the in the seismic loading conditions. So what we can see, even in the slopes also, with increase in the density, we are getting the more bearing capacity, and we are getting the clear failure surface also. You can say clear bearing capacity you can determine here. Here, this is the effect of the setback distance. If we increase the distance between the footing and the slope phase, bearing capacity is going to increase. If you keep your foundation very close to the slopes, what we are going to get? Lesser bearing capacity. So just I will go through this. So suppose what is the setback? Setback, you can see foundation is resting very close to the slopes. So we can say this is the one side failure surface. Here also, when we are increasing the distance between the slope phase and foundation, what we can see, the failure surface has become the symmetrical. Now in this condition, footing will behave like a footing resting on the level ground. So if we keep our foundation very away from the slope crest, I can get bearing capacity very much close to the level ground. So this is the effect of the setback distance. Here you can see depth of the foundation when footing is resting or at the ground surface. Very small area is there. You can see very small area contribute to the bearing capacity, or failure zone is very small. So it is independent of the slope effect. If you increase the depth of foundation, pressure is going to enlarge, and it is going to be affected by the slope effect. So when we are increasing the depth of foundation, what is happening? You can see with increase the depth of foundation, bearing capacity is increasing. But what is the problem here? The effect of slope is also increasing. What is the reason? Because when foundation is resting at a deeper depth, what is happening? The pressure valve is going to very large. When pressure valve is large, that pressure valve touches the ground surface also. Here, pressure valve doesn't touch the sloping surface. So footing is independent of the slopes. You can see here slope inclination when footing is resting on the level ground. It is perfectly symmetrical ground surface. You can see failure surface. When we are increasing the slope inclination, it is becoming the one side. So here you can see state is the bearing capacity failure. Up to the certain slope inclination, the failure is governed by the bearing capacity failure. But you can see here, it is a slope failure. So it is the, you can say, mix failure mechanism, slope as well as the shear failure. At the higher slope, it is going to completely the slope failure. That has been not considered in the present study. Now, what is the effect of internal friction angle of soil? If phi is very 0, pressure value is also going to 0. We can see here, very small soil is going to contribute to the bearing capacity. When increasing the phi, more pressure area is going to increase. So it is going to be affected by the slope effect. So when we are increasing the phi value, the bearing capacity increasing as well as the effect of slope is also increasing. You can see slope effect is also increasing, although bearing capacity is increasing. Now, if what you can say seismic loading is there, so when seismic loading is there, it is the bearing capacity failure. When we are increasing the seismic loading, it is becoming the slope failure. In case of, so this is the outcome of the study. If you can see how much, what is the major important factor. So we have considered in one case cohesionless soil, other case cohesive soil. So in case of the cohesionless soil, angle of internal friction is affecting the bearing capacity very highly, 39% importance factor. Relative importance, then slope inclination 25%, seismic acceleration 18%, depth of foundation 10%, setback distance almost the 8%. So we can see here phi is more important and the slope inclination. These two factors are very important. We are designing the foundations on the slopes. This seismic acceleration is also important, but compared to this, not so much. In case of the cohesive soil, again you can see strength is very important. Then slope inclination, same trend. So we can say that it is better to construct the buildings on the slopes, but by improving the properties of the soil. So we can construct on the slope also. If we can see, if you increase the phi value or increase the C value, their effect is going to more on the bearing capacity. Then how much distance we have to maintain between the slope crest. So you can see here, if this is the slope crest, 2 to 3 times of the footing breadth. So we cannot keep on the near to the slope. We have to keep our foundation away from the slope. So how much distance? If your soil is very big, 2 to 3 b. If your soil is very strong, because more strong soil, more load carrying capacity, more area is going to involve. So we have to keep foundation very away from our slope crest. So this is the something here. Similarly, critical distance for the cohesive soil also determined. Then these equations have been proposed. This is the slope factor. This is the bearing capacity factor. So these are the equations, critical setback distance. So if you know what is the slope inclination, what is the setback distance ratio, what is the phi value of the soil, if I know those parameters, I can keep those values here and we can get the bearing capacity directly using the, these are from the numerical study. Similarly, seismic case, some equations have been developed to determine the critical setback distance, to determine the seismic bearing capacity, to determine the slope factor. So this is the validation you can see. This is the predicted one, this is the determined one. So we have almost those equations predict these all the parameters almost very accurately. And this is the validation of our equation. So we have developed those equations based on the numerical studies and then have been validated with the experimental studies performed by the Keskin and the Lehman. So we can see that in the present case or in case of the numerical modeling, we have the little bit higher slope factor. It means the effect of slope is less. Similarly, again, we have compared the results with the so many studies, those equations results, not the study results. So our equations predict the bearing capacity factor on the slopes very accurately. We can see here when phi is small, it is almost average. When phi is increasing, in our case, we are getting the lower value of the bearing capacity compared to the earlier studies. Thank you, Dr. Neeraj.
Thank you, sir. Thank you, sir. That was a very good aggregation of all the concepts. If someone has to construct something on the slopes, I think you very well explained the constitutive modeling also, and also what are the various factors that actually contribute to the failure of the foundation, what is the effect of the depth and all. So thank you very much. That was a very informative lecture. With your kind permission, can we go to the question and answer session, please? Dr. Rajesh, can we please start the question and answer session?
Sure.
Okay. So first question is from Aman Mishra, how the vertical stress cannot vary with the slope in finite slope analysis, as we have assumed.
Okay, in finite slope, no, finite slope it is going to vary, we are saying. We never says ki stresses are not going to vary. In case of the finite slope, stresses are function of the depth.
Yeah.
That is not the assumptions even.
Yeah. Right. Another question from him is, if settlement is not given in upper and lower bound problem, then we can fulfill the research gap, sir. As in Plexus 2D or 3D, we use load settlement to analyze all the issues.
Like he's perfectly right. In case of the Plexus, you are going to get the load settlement curve. What is the problem there? Whether we know that is the real collapse load or not. In case of the Plexus, that follow the constitutive modeling, we don't know whether this is the close to the real collapse load, less than or more than. But when we are doing both upper as well as the lower bound, and if their results are almost same in the both the limits, then only we can show that my collapse load is very close to the real collapse load. So that is called the true bearing capacity. That has been determined the layman already. So that might be 2012 also. So somebody is interested. So he can go that research paper by the layman in 2002. He has given the exact bearing capacity. Same concept he has followed.
All right. So just for a moment, we have an important announcement that the Department of Civil Engineering, along with the IS Shimla chapter, is going to organize an international conference on civil materials and environment for sustainability. So the papers are invited. You may please go to the given link and attach your abstracts as per desired. Okay. Mr. Balram Nargave has raised his hand. So can you please unmute yourself and ask the question, please? Can you hear us, Mr. Balram? Okay, so we'll move to the next question now. It's from Shweta. Sir, I want to ask you, does the limit analysis have any kind of advantage? Why do people pick limit analysis over finite element for the research work?
See, limit analysis is different thing, finite element is different thing. I can perform the limit analysis even using the finite element also. Or I can perform the limit analysis using the analytical method. See, I can develop for the upper one, what we have to do? We have to get the what is the rate of work done by the external force that is acting on a foundation. If I know, because when load is applied, foundation is going to subject to the settlement. If I know what is the settlement, I know what is the load, I can get the rate of work done. Then I have to determine what is the rate of work done. Similarly, internal mechanism also offering the resistance to the failure or resistance to the loading. So there also some mechanism is there, like the C is going to be there, phi is also there. So that also offer the resistance. So we have to find out the equate both rate of work done by the external loading equal to the resistance or rate of work done by the internal resistance. Then I'm going to get the upper bound solution.
Yes, exactly. Both the things are possible side by side. So another question is from Amanji. How to overcome this problem to reduce the settlement in sloping side? Can we use SC or ESC?
You're not audible.
How to overcome this problem to reduce the settlement in sloping side? Can we use SC or ESC?
What is SC?
That is not defined, I think. Amanji, can you please unmute yourself and ask this question directly?
Sir, I'm talking about that stone column and encased stone column.
All right.
Okay. So, see, that is, we cannot use, even we can use the set piles. That is better solution, economical solution.
Okay, if differential settlement will be
that he is right, we can reduce the settlement, that is right. But again, we might have the number of solutions to reduce the settlement or to produce the passive force, passive resistance toward the slope side. So many people have used the retaining walls also. Some people have used the seat pile. Some people have used the other methods also to reduce or increase the passive resistance toward from the sloping side. So there are a number of methods and studies are available in the literature to increase the passive resistance or increase the factor of safety.
Sir, as per the Indian condition, what will be the better option, sir?
See, Indian conditions, is soil is going to vary so much. Like the concrete, if you're dealing with the concrete, any material, we know every constituent how it is going to behave. But in case of the soil, we cannot seek any general solution. That is the consultancy is there for a particular soil condition, particular drainage condition, particular boundary condition. We have to find out the one particular solution. So we cannot have the universal solution for any problem. If problem is not identified, we cannot give the solutions.
Yeah, that will depend on many of the other conditions also. When
So
we are
many conditions are there. How much money do you have? Party is there. If suppose he wanted to do ground improvement, how much money do you have that party? We cannot go for soil. So there are so many factors when we are selecting the ground improvement technique. Just not only the money.
Yeah. To add to it, there are also some space constraints many of the time, and according to them
yes,
also,
you're right, Neeraj. Dr. Neeraj.
According to that also, we have to choose the solution.
And in the slope case, if you're using the slopes, even during the what you can say ground improvement, slope might fail also. We cannot bring the heavy machineries there also. So when you're dealing with the stability of slopes, we have to be very careful also. There are so many restrictions then again.
Yes, right.
Okay, sir. Thank you, sir.
Okay, so we'll move on to next question. Is from Rasimran Jan Samal. How to find factor of safety of slope in a small scale model test?
See, in a small scale model test, like in my case, I have shown you some pictures. Also, first thing is it is very difficult to make the slopes there. And that also see in case of cohesion soil, what you can say, cohesive soil, it is very difficult to simulate in the small scale testing. But if soil is your sand, then it is very easy comparatively. And we have to determine what you can say, factor of safety, how much load it is taking before what is the failures it developing. Along that, what is the C and phi, when you are applying the loading on top of that, how it is developing, you can find out what is load there, and be in the level ground and in the sloping ground. In that way, I can find out the factor of safety. Or we have to observe what is the failure surface developed, what is the length there, in case of the sloping ground, in case of the level ground, how the failure is developing. So that length extent is also there, and I know the properties, then I can determine the factor of safety there.
Right. There's another question from him. How to find factor of safety of slope in experimental? I think that's a repeat question.
Same question.
Yeah. So next question is from Abdul Rafiji. Sir, is it possible to initially the ground will be horizontal on both sides, then one side horizontal can convert into sloping? I think you want to ask if the ground is initially horizontal and then one side becomes a slope and one side remains horizontal. Is it possible?
It is possible. Many cases, many times you can see in the hill region it is possible.
Yeah, many a times one side of the slope is shrugs off. And
yes.
Then the building is subjected to such condition when one
in our
side
case, what is happening, there is one building in Srinagar itself. So that is the KV building actually. So what they have used, that is not on the hilly region. What is happening, they have used in the fill. Half of the building on the original ground, half of the building on the filling. So half of building, both buildings are connected, and half building has been just tilted. So we have just visited few days back there. So these type of problems are coming. So it is just tilted. There is possibility that filled material have been gone also with the rainfall. So this is possible.
Exactly. To add to it, Dr. Rajesh, we are also facing such problems here in the region. Many a times when the people are not so much educated about this bearing capacity determination on the slopes, they usually go through such problems. If that comes, I'll definitely get back to you.
So actually, see, in case of the slopes, what can be better solution? Don't go for the deep foundation really, because most of the time the cost of deep foundation is very high. It involves the vibrations. Also, so many issues are there with the big deep foundation. So first, we are going to explore as a ground improvement initiation with the shallow foundation. If we found that the cost of the ground improvement and the shallow foundation is less than the deep foundation, it is better to go for with that option, because ultimately we have to save money also there in our developing country. Right. If that is option is not there, then we live with the only deep foundation only.
Right. So next question is from Vishnuji. Does placing a gabion wall at the edge of a slope create failure?
Create failure?
Yeah, he has written, can it create a failure?
Beyond how it can create the failure, I do not understand the question actually.
The gibbon wall is generally for retaining the things. Yeah.
He wanted to say, man, whether it can provide the safety to the slope or not. Obviously, it will provide the safety, but not so significantly.
Yeah. There's another question from Mr. Aman. What novelty can we think in this case of slope stabilization using shallow foundation in any general problem?
If you're using the, what is the question?
What novelty can we think in this case of slope stabilization using shallow foundation? I mean, he's asking about the generalization of the problem.
No, I think he's interested in what is the solution, what is the new problems. If foundation, shallow foundation is there, now if you are using the ground improvement technique, this ground improvement technique can be used. So if you see, number of research have been used the geosynthetic, some have used the, what you can say, row of pile walls or seed piles also. So we have to think, we have to make the economical study also. Till now, there is no economical studies. So we can go for the different methods, small scale or full scale. If you're using the software, we can go for the full scale testing. And then we can find out what is the cost involved there. So till now, no one has compared there. So we cannot say that this method is having the more economical. So from that perspective, that is the real condition, or one contractor or one construction management company might be interested.
Absolutely. There's another question from Rasimaranjan. What are the dimension scaling law regarding model test for prototype and model?
See, then whatever is scaling problem, basically whether you want to model the isolated foundation or the strip footing, that is also a matter. So when you're modeling, what we have to maintain the plane strength condition. If you're modeling the strip foundation, it means your foundation from the side, suppose this is the wall of wall of the tank, and between I'm keeping one foundation. So what resistance should come the sides also. If you're keeping so much significant gap there, so foundation will go laterally also. So that means not remaining in the plane strength condition. So what things is there, you should maintain that also plane strength conditions in case of the slope. If it is a suppose isolated foundation, we don't have to worry about them so much there. Directly keep the foundation on the slopes and do the testing.
Boundary effects, do we call that? If I'm right.
There is the boundary effect. Then density also, so many things are there. We have to check whether that density, whatever we are thinking, we are receiving or not.
Absolutely. There is another question from Sudhir Kumar Jala. Could you see, sir, which software tool you were used for slope study with effect of with seismic effect? Results show that conservative side most of the results, and secondly, it seems most of your hypothetical cases show the gentle slopes. If slopes are little steeper, more than 45 degrees, which analysis do you suggest?
See, there are a number of, like, we can go for the Plexus, we can go for the GeoStudio, we can go for the Optum. It depends on the when in this software you are very friendly. That is the first issue. Second issue is that slope. So what in the present case we have considered the finite slope. That also is stable slope. So like some cases have been considered for suppose phi equal to 25. So we cannot go for the phi slope inclination more than 20. Some cases might have not able to present here. If suppose maximum phi is 45. So we cannot go more than the 45 slope inclination. If it is a C5 soil, then we can go for the more than slope also. I have not presented the result of cohesive soil. In case of the cohesive soil, we have considered the slope inclination of 70 degree also. The reason is that in case of the cohesive soils, that slope is going to stable temporarily, not permanently, long term. For the short term, it is going to stable even 70 degree slope also, if C is very high. So that I have not shown in case in the present study, but that is also possible. But in case of the clay, where that also the short-term condition, not in the long-term condition.
Right. I hope that is a satisfactory answer. There is another one query from Rasimaranjan. If I want to model 30-meter height slope into 30 centimeter slope in a small scale model in test tank, what are the scaling law?
What is there? What is he asking?
I think he's trying to model a 30-meter slope into a 30 centimeters height slope, 1:100 scale.
Okay.
Then he wants to ask, what are the scaling laws for that?
See, that we have to go for the dimensional analysis given in the fluid mechanics already there. So there are a number of rules there. What parameters, whether you're trying to find the stresses or the strain, what is your what you can say parameter of interest. Depending on that, you have to do the dimensional analysis. How much factor is going to there. Say factor.
Right. Maybe Dr. Rajesh, if you can suggest some of your paper where you have mentioned those details of the dimension analysis, that will be good for.
Okay. Hi, they can search in the what you can say ResearchGate. They can find out most of the papers. So now basically I'm working on the bucket foundation. We have started just recently working on the bucket foundation. So we did some analysis on the bucket foundation on the level ground. Bucket means generally we can see in the offshore structures, it is difficult to make the excavation and do the pile. So nowadays bucket foundation is becoming so much popular. Especially China have made really very big bucket foundation. And installation is very easy for those foundations. They are the ready-made thing and they're just going to install there, drive there using the machine. So nowadays, so now I have started working on the bucket foundation on the slopes for the different soil conditions and slope conditions. Some papers are under review. Two are is just that bucket foundation paper is under review in the ASC. So let us see how review is coming. Then he can able to download from the ResearchGate. Let it published.
Right. So there's another question from Sona Thomas. Sir, while preparing slopes, use sand in scale slope models. At what density should we prepare slopes?
Okay. See, it depends on the what density height. See, we cannot keep the so much height. After some height, so rain it is not going to give the rainfall effect. It is just going to offer the distance by the drag. So we cannot reach so much relative density. We can go for the maybe 30 to the maximum. We can go for the maybe 80 something like that relative density in the experiment. We cannot go more than that. So you can what you can do, whatever rainfall he has, some equipment he might be having rainfall to fall the sand from particular height. So he can do from the small height to the maximum height, whatever possible. And he can see how much density he is achieving. So depending on that, what is the upper limit, what is the lower limit of the relative density he's getting in is that mechanism particular. That also affected by the wash technique of he's using to fall the sand. Whether it is through the pressure, he's using the pump also to fall, that also going to affect. Whether he's using the manual things there. So that is going to affect the relative density, just not only the height of the sand. What type of sand also going to affect, whether it is the uniform sand or it is the well distributed, what is there. So relative density is function of so many things there. How much I can achieve.
Absolutely, that's has nothing to do with the maximum MDD that is possible in the lab. That is all about the rainfall simulation technique, and then whatever this relative density you can achieve in the most practical manner. I mean, in that you can model your thing. Okay, so next question is from Panuganti Aditya. Regarding slope foundations, is there any dilatancy effect in slopes? What is the effect of the dilatancy?
Yes, there will be dilatancy effect. So it depends on the study to study. In case of the what you can say, small scale testing, it is very difficult to see the dilatancy effect. We cannot see because the induced stresses are very small there. But in case of full scale testing, we can see their effect also. So you have to use the what you can say dilatancy effect in your studies. So it's all depend whether you're considering dilatancy effect in your study or not. So all the software, whatever common softwares here, they are able to handle the effect of the dilatancy very clearly. So they have to define what is the dilatancy angle there. Based on that, it will change the results.
Absolutely. There's another question from Ayush Gupta.
Or other issue is that, Neeraj, just 1 minute. Already there are equations are given by the different researcher also to consider the effect of dilatancy. Suppose in your study, you are not able to consider the effect of dilatancy. So I can modify my bearing capacity factor, or I can modify my bearing capacity itself using those equations to consider the effect of dilatancy. And dilatancy is not possible in case of the what you can say loose sand also. So that also we have to see whether we are really applying to the real case where dilatancy is possible or not.
Yeah. Good to see a lot of students are having a keen interest in your lecture. They are keeping on asking questions. So another question is from Ayush Gupta. So he is referring to one special case in the Ramban in JNK, where over 50 houses were damaged and 500 people had to be relocated due to sudden sinking of the land. So do you have any comment on that?
I don't have any idea about that case.
Okay, sorry for you.
I have to see that what is the case actually. Then only we can have any comment.
Right. There's another question from Mr. Sher Bahadur. Thank you,
Sir,
sir.
okay.
Thank you for joining us.
Sir, good afternoon, sir.
So question is, what precautionary measures are taken by real estate builders in construction of building in Joshimath area? Do they know all these regulatory measures to be adopted so as to avert any failure on account of settlement or failure in bearing capacity of soil?
See, what is happening in the Joshimath, what I think, I don't know really the case there. So those are the hilly regions. They are not the perfectly stable. They have the soil also there so much. So much they are making, so much building, so much hotels there, so many things there. So that is instabilizing the the region only. Capacity is less than there. So they're making the buildings, houses so much the allowable also. So government has already restricted. You cannot make the new construction. But people still make the homes, hotels there. So many people are coming there. So much vehicles are coming there. And they are creating so much dynamic loading also there. And they're not following any government guidelines there.
Yeah, I think that's very correct because those regulations were not in place.
And most of things there, that is the settlement failure there. Recently, there is a settlement failure. Many buildings are intact. They have settled by the 0.5 meter also. Some building 0.7 meters also. And buildings is intact there.
Okay, I hope that would have been clarified. So if any participants want to ask the question to the speaker directly, they can unmute themselves and ask the question. Okay, I think Dr. Rajesh, we are done with the questions hereby.
Thank you, Dr. Anil. I am really grateful to you, as well as our Professor A.K. Gupta, sir, Dean Academics and Research. Really. Thank you, sir. Good afternoon, sir, if you are present here.
I think he is in meeting today. Some PhD vibe is going on. Anyway, Dr. Rajesh, a big thanks to you for deriving a lot of precious time of yours. And on behalf of entire IGS chapter Shimla, and also Jaypee University, I thank you for coming here and educating us.
Thank you. Thank you so much, Srinivas. This is really great privilege to have the lecture with the Samadhiya sir and what you can say our IGS president. So I'm grateful to you. Thank you.
Yeah. Mr. Balram, you have raised your hand. You have any queries? I think. Okay. Thank you to all the participants. I have already shared the feedback link. I think you have got that. I'll share it again. And this entire lecture thing will end in like 10 minutes. So please fill your feedback link within that time. So thank you. Thank you to all the participants, to the faculties, and to all the students who were present. And we'll meet again tomorrow at 11 a.m. There's a very important lecture by Dr. Nilima Satyam over the landslide hazards in Himalayas. So please join us tomorrow again at 11. Thank you.